Welcome to radical expression equations. These will be equations that have one or more radical symbol. This is part of algebra, and it is an algebraic technique to solve them. When an equation has one or more radical expressions, or fractional exponents, in other words, it might be parentheses x minus 1 close parentheses to the 1/2 power, or it might be a square root symbol. They handled identically. The technique is to isolate one of the radicals on one side of the equation. Multipliers may remain as coefficients through the radical. Raise both sides of the equation to the appropriate power to remove the isolated radical. Repeat as many times as needed. Solve the resulting equation and check the answers if an even power is used to eliminate the radical. So a little discussion about the even power. If you raise an equation to an even power, you can introduce solutions to the new equation that are not solutions to the original equation. These would be considered extraneous solutions. So as an example, if I have the square root of x plus 1 equals x plus 1, is handled by squaring both sides of the equation. So we square the square root of x plus 1, and we square x plus 1. Now, checking when raising to an even power is required, it is possible that we would introduce extraneous solutions. So when we do raise to an even power, we need to check the solutions. Extraneous solutions are solutions to a new equation that do not solve the original equation. As a simple example, x equals 9 has only 9 as a solution, but x squared equals 81, both sides squared, has negative 9 and 9 as solutions. Notice negative 9 does not solve the original equation, hence the need for checking. Now, if you're taking an odd power, if you have x cubed equals something, and you raise, or the cube root of x equals something, and you raise both sides to the third power, there is no danger, because the cube root of, say, negative 8 is negative 2. We get only one real solution. So we're going to start with a simple example. The square root of x plus 3 equals 2. Here the radical is already isolated, so I'm going to square both sides. I'm going to square x plus 3, the square root of x plus 3, and I'm going to square the 2. So I get x plus 3 equals 4. I solve that equation, and a lot of the equations you will get will be linear. Sometimes they will be quadratic. We're not getting exotic equations out of these problems. So if I subtract 3 from each side, x plus 3 minus 3 will leave me x, and 4 minus 3 will leave me 1. Checking is required. The square root of 1 plus 3 is the square root of 4, which is 2. And if I plug the 2 in the other side of the equation, Well, the other side has only a number, and that number is 2. There's something to plug in. So it's accepted as the solution, the number 2, x equals 2. Now, here we have a problem, especially with quadratics. Some students assume that if they're solving a problem that results in a quadratic, that one of the solutions will be good and the other not. That's not true. Sometimes both are good, sometimes neither are good, and sometimes it's 1 and 1. Here with the linear equation, sometimes we get a solution that is good, and sometimes we do not. Now, next example, the square root of 4x plus 4 minus 1 equals x. So we're going to isolate the radical term, the square root of 4x plus 4. So we take the negative 1 plus 1, and that will go away. And that's equal to x plus 1. So I'll square both sides. I'm going to eliminate the radical by squaring. So the square root of 4x plus 4 squared equals x plus 1 squared. So I get 4x plus 4 equals. Now when I square x plus 1, it is not x squared plus 1 squared. We have to use polynomial multiplication. X plus 1 times x plus 1, which will be x squared plus 2x plus 1. So I have a quadratic. And getting everything to one side, which is the way we solve a quadratic, we get 0 on one side equals, we have an x squared. The 4x becomes a negative 4x plus 2x becomes negative 2x. And the 4 becomes a negative 4 plus 1 is negative 3. So I have a quadratic. This one happens to factor. It's still guaranteed that you will get something that will factor. It factors as x minus 3 times x plus 1. And we set that equal to 0. Now, when we factor, there's a powerful rule in algebra. And it works with the number 0 and only with the number 0. If I have two numbers that are multiplied together, and that product equals 0, at least one of those two numbers is 0. There's no way to get a 0 multiplying a 4 and a 5 or a 3 and a 2. It has to be that one of those two numbers is a 0. So I get x minus 3 equals 0. Gives me x equals 3. And I get x plus 1 equals 0. Gives me x equals negative 1. So I'm going to check. I have to go back to the original equation to check. So I have the square root of 4 times 3 plus 4 is 12 plus 4 minus 1. So I got the square root of 16 minus 1, or the square root of 16 is 4. 4 minus 1 is 3. On the other side, if I plug a 3 in, I get 3. So this one checks. The negative 1, plug in the negative 1 for x. 4 times the negative 1 plus 4 is 0. Minus 1 equals 0. Minus 1 is minus 1. I plug the negative 1 in for x, I get negative 1. So we would accept both solutions. An example with two radical symbols, the square root of x plus 3 equals 1 plus the square root of 6x minus 5. Since one radical is isolated, just go ahead and square both sides. So we'll get the square root of x plus 3 squared equals 1 plus the square root of 6x minus 5 squared. Well, on the left, I get x plus 3. On the right, I treat this with the same technique of binomial multiplication. I take FOIL works just fine. I'll have this expression times itself. 1 times 1 is 1. 1 times the square root of 6x minus 5 plus 1 times the square root of 6x minus 5 is 2 times the square root of 6x minus 5. And 6x minus 5, the square root of 6x minus 5 times itself is 6x minus 5. So then I will isolate the second radical. So I have x plus 3 minus 1, bringing the 1 over, minus 6x, bringing the 6x over, plus 5, bringing the 5 over, equals 2 times the square root of 6x minus 5. So collecting like terms, I get negative 5x plus 7 equals 2 times the square root of 6x minus 5. Well, if I square both sides, I have the negative 5x plus 7 times itself. And that will give me negative 5x times negative 5x is 25x squared. Negative 5x times 7 and another negative 5x times 7 is negative 70x. And 7 times 7 is 49. On the other side, do remember to square the 2. It becomes a 4. And the radical symbol disappears. So you got 4 times 6x minus 5, which is 24x minus 20. So we have a quadratic, 25x squared. We have a negative 70x, and over here I have 24x. So I subtract that. I get negative 94x, and 49 plus 20, I get 69. And the quadratic, of course, is equal to 0. So I will factor this, and yes, it does factor. X minus 1 times 25x minus 69. So I'll set x minus 1 equals 0, and I get x equal 1. I get 25x minus 69 equals 0, and I'll get x equals 69 over 25. So I have two candidates, 1 and 69 over 25. Well, plugging the 1 in, and back to the original equation with the plug-in, the square root of 1 plus 3 is the square root of 4, that's 2. That's equal to the square root of 6 times 1 minus 5, or 1. And 1 plus 1 is 2. So that one checks. The square root of 69 over 25 plus 3 is not equal to 1 times the square root of 6 times 69 over 25 minus 5. So I would reject the second solution. To actually leave the square root of has a plus 2 higher on one side than on the other. So this is the technique. would appreciate if you would hit the subscribe button and watch what I've been putting practice sets up in addition to the theory. The theory has, of course, come first. So if you're looking for the practice, I will probably put about 10 problems set up in a not too distant future. If you want to see a different topic, just go ahead and leave a comment and tell me you need a different topic and I can see about getting it. Thank you.